going to start today off just by going over some inequality vocabulary. So I want you to pause the video and just read over these vocabulary words. The first one is greater than. The second column is less than. The third column is greater than or equal to. And the last column is less than or equal to. So these are keywords that we look for in word problems that help us determine what inequality symbol we're going to use when we translate the verbal expressions to inequalities that we can solve, or if we're looking at word problems that we need to write inequalities for in order to solve them. Example 1, we have 5 less than a number x is under 20. So keywords that we need to take from this are less than and under. I'm highlighting less than because when we see 5 less than a number, that means we need to write the number first and use subtraction to represent less than and 5. When I see less than in a verbal description or in a word problem, I just have to remember to flip-flop the numbers around less than. Less than is going to tell us to use subtraction, but I have to flip-flop the numbers around them. And then when we see under, the inequality that under tells us to use is less than. Now we would solve this by performing our inverse order of operations. So first we need to add 5 to both sides, which cancels out the 5 on the left, leaving us with our final answer, which is x is less than 25. Example 2 says the sum of negative 3x and 7 is at least 22. So we know we're performing addition where we see the word and because it's at least, we know we're going to use the greater than or equal to symbol. So I'm going to write my algebraic inequality, negative 3x plus 7 greater than or equal to 22. Now this inequality is going to require 2 steps in order for us to solve it. So using our inverse operations, I'm going to first start with subtracting 7 on both sides. So that way I cancel out the 7 on the left-hand side, and that leaves negative 3x on the left. We bring down our inequality symbol, which is greater than or equal to, and we have 15 on the right. Now I need to isolate x by doing the inverse of multiplication, which is division. On the left-hand side, it cancels out the negative 3, leaving us with just x on the left. But because I divided by a negative number, I'm just circling my inequality symbol so that I remember it needs to switch directions. Important rule when solving inequalities is that when you multiply or divide by a negative number, you have to switch the direction of the sign. So my final answer here is x is less than or equal to negative 5. Example 3 is a word problem. You want to fence in a flower garden. You have at most 42 feet of fence. The width of the garden needs to be 12 feet. What are the possible lengths of your garden? There's a lot of important information we need to take away from this word problem in order for us to solve it. So I know I'm talking about a flower garden. It has to be at most 42 feet of fence. So I know I'm talking about the outside of my flower garden. It's a perimeter for the flower garden. So I can say that I know the perimeter is 42 feet at most. Just reminding myself that we're talking about an inequality here. We know the width of the garden needs to be 12 feet. And that's super important here because on our garden we know this has to be 12 and this has to be 12. We need to know what the possible lengths are. So our length is what is unknown here. But because it's an inequality, we have a ton of different possible lengths that we can use. So to write this inequality, I first need to remember that perimeter is going to be 2 times the length plus 2 times the width, gives us our perimeter. But it needs to be at most 42 feet. So it's going to have to be less than or equal to 42. So now I'm going to plug in all of the information that I already know into this formula that I wrote so that we can solve this and find the possible lengths. So we have 2L, because we still don't know what the lengths are, plus 2 times 12, because we know that the width of the garden has to be 12. And our inequality, less than or equal to 42, because that's the most amount of fencing that we can use. So let's start by simplifying what we have on the left-hand side of this inequality. We have 2L plus 24 is less than or equal to 42. Now I need to isolate my variable, so I'm going to perform the inverse order of operations. I'm going to subtract 24 from both sides of this inequality, canceling it out on the left-hand side, leaving me with 2L is less than or equal to 18. And my last step is going to be to divide both sides of the inequality by 2 so that I find L has to be less than or equal to 9 feet. So the answer to this problem is that the possible lengths of the garden are 1, 2, 3, 4, 5, 6, 7, 8, or 9 feet. Anything where the length is 9 feet or less is a possible length of this garden. Example number 4 says, in the summer you sell lemonade and you charge 50 cents for each cup. It costs you 30 cents to make each cup of lemonade. How many cups do you have to sell to make more than $20? So writing these inequalities is just like writing any regular equation that we would solve, but because it's an inequality, we're going to have a range of answers. So I'm going to go through, highlight the important information from this word problem so that we can write our inequality in order to find our answers. You charge 50 cents for each cup. It costs you 30 cents to make each cup, and you want to know how many cups do you have to sell to make more than $20? So what we're looking for here is the number of cups you have to sell. So we're going to let our variable C equal the number of cups you have to sell. We already know that you charge 50 cents per cup, so that's why I'm writing 0.50 times C. But it costs you 30 cents to make each cup of lemonade. So that's why I'm going to subtract 0.30 times C, because that's the money you spent making each cup of lemonade, and you have to take that away from what you charge making for selling each cup of lemonade, because the difference there is going to be your profit from each cup. We want to know when that's going to be more than, so when is it going to be greater than 20? So first step here is we're going to combine our like terms. So 0.5C minus 0.3C leaves us with 0.2 or 0.20C, and that needs to be greater than 20. Second step is to divide both sides of this inequality by 0.20. On the left, it cancels out because we performed the inverse operation of multiplication. So we divided on both sides, leaving us with C is greater than 100. So you need to sell more than or greater than 100 cups to make more than $20? And that's the final answer for the lemonade stand problem. So that's it, everyone. I hope you enjoyed this video. Don't forget to like, share, and subscribe, and I'll see you guys next time.